I know. Good name.
All right, guys, what we're looking at here is remembering these. This should, Uber groups. Uber groups, that's right. So hopefully we can do this without looking up in our 7th grade notebooks. And hopefully the groups themselves are not giving us trouble. But in doing this today, we're gonna look at some of the real number things, like remembering how to estimate square roots and maybe how to change fractions to decimals. Just like quick reviews of how do you look at real numbers altogether. So, real was what?
Whole number.
No, that's a number.
Rational.
How about you raise your hands? Because I can't hear all of you at once. Rashawn?
Rational.
That's another group we're gonna get to. Caleb?
They were real numbers, like actual numbers, like all numbers.
All numbers, any number.
Do we write this down?
Well, you're not remembering it, so I would suggest you write it down.
Okay.
Yes. Then, after you go to real, remember we have rational and irrational. I'll put one up at a time, and I'm gonna draw that. Do you remember that Venn diagram we did with this?
Yeah.
Okay, I'll draw that up here in a little bit. Rational, Preston?
It's a number that ends.
And so it's a terminating decimal, I can't even talk, terminating decimal. Or, Preston, do you remember what other happens with, if it's a decimal form? It can be an ending one or,
A repeating one.
yes. So it's gotta have some pattern to it. What about, is that the only form a rational number takes? Does anybody take it from there? Remember this? Does that help you? What does a ratio look like? What's the most common form of a ratio? Olivia? A fraction. Okay, so we have rational. We go with irrational. Basically, not rational, right? I mean, so rational number would be, I'll put up examples shortly when we go through the rest of it, but you know, rational would be like 0.5, 0.3 repeating, 1/3, -4/5. But here you have ones like 0.1256 ... pi, square root of 5, stuff like that. There's an easy one, right? How do you define a whole number? Lily?
No decimals.
Okay, and actually, we'll expand that to say no parts, right? No decimals or fractions. And what does it start with, Lily, remember? What's the first whole number?
What's the first?
What's the first whole number?
0?
Yes. Good. Okay, then we get to integers, which uses whole numbers. How? Evelyn, do you remember? Think of integers. What are examples of integers?
1 and 1/4. 1 and 1/4.
1 and 1/4? No. No. Think of a number line. And like our rules of adding integers and subtracting and multiplying integers. Lisa, you remember? All those were adding integer rules. What kind of numbers did we use? I think we'll be reviewing those too. Olivia?
Negative.
Negatives, yes. And negatives on what?
A number.
That's true. It basically is all the whole numbers, so there's your 0, 1, 2, 3, 4, 5, etc. And they're, what's the best word to put there? Not negatives. What'd you say?
Counterpart?
You are in definitely the right territory, not the word I was thinking of. Can you think of a different word? More of a math word?
Opposite.
There you go. Good job. I'm gonna go to another slide because I don't wanna mush them in. I got one more. Anybody need more time writing that?
Mine. I mean, yeah.
Yes, good.
Yeah.
Natural numbers? Oh, what do you think natural numbers are?
Like 2,
2 is a natural number.
4,
Mm-hmm.
6.
Are they only even?
No.
Are they only positive?
Yes.
Are they only things without parts?
Wait, what?
Are they only numbers without parts?
Yes.
Okay. So you're describing numbers like 1, 2, 3, 4, 5, 6.
Mm-hmm.
Yes. Otherwise known as counting numbers. Right? So you have real numbers. This is what you have probably in your 7th grade notebook here. Whoops, we're not gonna do this. And on one side, we have rational. Actually, let's just use abbreviations. And the other side, we have irrational. Who remembers what the next biggest one is? Think about, we have natural, whole, and integers left. What do you think the biggest one out of those three are? Rashawn?
Wait, what do you say?
He asking you to repeat.
Yeah, what?
Yeah, we still have these three. Which one's biggest? Which one has the most numbers in it?
Oh, sorry. Integers?
Mm-hmm, you're right. Because it's got all the negatives, where these two don't. Right, what's next? We have whole and natural. Which one's got more numbers, Caleb? Whole, and why? It's got 0. That's the only difference. So one way to remember when you're looking at that, I think real broken up into irrational and rational, it's pretty easy to remember. The fact that nothing else is irrational, kind of easy to remember. So this is where people mix up the most. Just remember it does not spell win. So that's something helpful. But here's your naturals. Here's your wholes. So that's why it's a little bit bigger. And then here's your integers. See, so that's why they're in the order that they are. Then rationals would be all the numbers in between them. And real numbers, no matter what, you have nothing. Oh. Okay. So, look at the